Hello guys. In the following presentation, we will discuss density, mass, and volume, where these values are extensively used in sciences. So everything around us has a mass and a volume, where everything having mass and volume is matter. Mass is the measurement of the amount of matter contained. So the more matter a thing has, the larger is its mass. More matter is a larger mass. And the metric unit of mass is a kilogram. Next, the volume is the measure of the occupied space, where the metric unit of volume is a cubic meter, or we sometimes say meter cubed. The relation between mass and volume is the density, where density is mass in a unit of volume. To better visualize, understand, and memorize the relations between density, mass, and volume, and learn their formulae, let's thoroughly examine the following formula triangle that summarizes all formulae including density, mass, and volume. So this triangle is similar to the one that summarizes the formulae of distance, time, and speed. At the top of the triangle is the mass, whereby density and volume are at the bottom. And it does not matter which one is to the right or to the left, since the same formulae and relations are reached given that both are at the bottom of the triangle. Firstly, mass on the top is equal to the product of the bottom terms, which is density times volume. Again, mass on top is equal to density times volume. Then to calculate volume, we hide it this way and check the triangle. So volume is equal to mass on top over density. This is mass divided by density. And to find density, we hide density and check the triangle, where density is equal to mass over volume as shown. This is mass divided by volume. So if we memorize this formula triangle of mass, density, and volume, we can at any time formulate the formulae of density, mass, and volume. So mass is on top and density and volume are at the bottom. Let's go over the following example to better understand how do we approach a problem involving density, mass, and volume. A 20 grams block of wood has a volume of 50 cubic centimeters. 20 grams of wood means that the mass of the object is equal to 20 grams, and the volume is given to be 50 cubic centimeters. Part A asks us to calculate the density of the wooden block in grams per cubic centimeter. Let's recall the formula triangle that we should memorize. Then density is equal to mass divided by volume. It's mass over volume. So given a block of wood of mass 20 grams and volume 50 cubic centimeters, we should find the value of density based on the values of mass and volume. Density is equal to mass on top divided by volume below. Mass is equal to 20 grams over the volume, which is equal to 50 cubic centimeters. This is equal to 0.4 grams per cubic centimeter. So in part A, we calculated density in grams per cubic centimeter. Next, in part B, what is the density in kilograms per cubic meter? So we should convert density from grams per cubic centimeter to kilograms per cubic meter. Thus, we should convert the unit of mass and the unit of volume. First, we know that every 1 kilogram is equal to 1000 grams. So to convert from grams to kilograms, and since a gram is less than a kilogram, we divide by 1000. So 0.4 grams per cubic centimeter is equal to 0.4 divided by 1000 kilograms per cubic centimeter. At this stage, we're only converting mass, so volume is still in cubic centimeters. This is equal to 0.0004 kilograms per cubic centimeter. Next, we'll convert kilograms per cubic centimeter to kilograms per cubic meter. We know that 1 meter is equal to 100 centimeters. Then 1 cubic meter is equal to 100 to the power of 3 cubic centimeters. This is equal to 100 multiplied by 100 multiplied by 100, which is equal to 1 million cubic centimeters. Next, we will convert from kilograms per cubic centimeter to kilograms per cubic meter. Since a cubic centimeter is smaller than a cubic meter, thus 1 over a cubic centimeter is larger than 1 over a cubic meter. So to convert 1 over a cubic centimeter to 1 over a cubic meter, we multiply by 1 million. Again, since 1 over a cubic meter is smaller than 1 over a cubic centimeter. Therefore, 0.0004 kilograms per cubic centimeter is equal to 0.0004 multiplied by 1 million kilograms per cubic meter. This is equal to 400 kilograms per cubic meter. Let's go over this one more time. A cubic centimeter is less than a cubic meter. But since it is in the denominator of the unit, and as the denominator increases, the value of the fraction decreases at a constant numerator, then 1 divided by a cubic centimeter, or 1 over a cubic centimeter, is larger than 1 over a cubic meter. And converting from the larger unit to the smaller unit, we multiply by the enlarging factor, which is a 1 million. So it enlarges the value that it is multiplied by, where this was derived as seen to the right.